And so now I'd like to introduce the next part of the discussion, which is around still talking about our development kit heroes. This is in association with the Element 14 community, and some of its top members. We're discussing our kind of heroes of the dev kit space. And we have a number of people on the Hangout today. We've got myself, Jen Patterson. I'm the European PR Manager. We've also got Cliff Altmaier, who is the Global Head of Development Solutions. We've got Steve Donaldson, John Alexander, Shabazz Yosaf, and Peter Oakes, and Michael Kellett, who are all top members from the Element 14 community. So I'll hand over to you, Cliff, now, and you can tee up the last question in this series. Thanks very much.
Great. Thanks, Jen. We've done a lot of discussions around boards and components, but what I'd like to talk about right now is technologies. Obviously, in terms of microcontrollers and processors, everybody, most of the major manufacturers have a pretty good covering across, covering most of those bases. But now when we talk about technologies, let's talk about motor control, wireless, sensors. I mean, obviously MEMS sensing is exploding now. Everything that you got in your phone, you now have access to basically, on your desk right now. In terms of the manufacturers, who do you think has, and we can start by, picking some of them, who has the best technologies, support, and even when it comes right down to it, things like motor control, who has the best development platforms in your mind for a particular technology or somebody that stands out? So I guess a couple of the major ones would be motor control and sensing. Any clear winners in that space from anybody's mind?
I mean, for motor control so far, we've been using a lot of Freescale, but we're looking at Infineon as well at the moment. So,
okay, and is that because of from the processor standpoint, or I mean, when you're looking at something like motor control, are you looking? Obviously, you've got the processor and all of the timers and all the all the peripherals that are built in. But what about from the driver stage and the support there? Are you looking for support from one manufacturer for the analog portion as well?
Yeah, definitely. Sorry, when I said Freescale, I meant on semi.
Yeah.
Yeah. So basically, you're absolutely right. I mean, if the data sheets have got lots of useful information, then we'll make use of that as much as we can because it just saves time. Mm-hmm. And definitely with high current, high power, I'd like to see data sheets containing as much information as possible, and sometimes it's not possible always to get the dev board for some of these devices. Mm-hmm. It would be nice if the manufacturers did supply those.
Oh, okay. Anybody else?
Probably right there with the ON semiconductor because they've obviously got the automotive heritage in there, and that really does make a big difference. And I think their stuff just works. I mean, where you see a lot of other providers sort of gilding the lily, right? The ON semiconductor, the prices seem to be very competitive, right? Even in the low quantities, and they do just work. And I mean, the only problem is sometimes they use some quite sort of awkward packages, obviously being high-powered devices. Right, and as Shabazz says, it would be nice to see them on a bit of a dev board, so you don't have to deal with that particular layout issue. So obviously, with a high frequency, you've got the high frequency sort of issues, but conversely, with the low frequency but very high power, you've got to lay out that track so it does work right first time. So last thing you obviously want is too much magic smoke released. So. Yeah, you always like the idea, that especially some of these devices when you look so incredibly small, right? And they are literally the size of a pin of a head, and that thing, and it's sitting on the board, and you think, how can that deal with 40-50 amps? I just don't believe it, but obviously do. But the design constraints are quite tight.
Now, are you guys referring to more along the lines of stepper motors and DC motors, or what about when we're talking about permanent magnet or BLDC, field-oriented control? Does anybody have a particular Is anybody very strong in that particular area that you see?
I'm not commenting on this because I don't really do motor control, so
No,
it's only a peripheral thing for me. So
okay.
It's not that I'm ignoring you, just don't really have much to add.
Oh, we got more technologies. Don't worry, we'll get you in here.
I've used, a lot of times it depends on the level that you're running. I worked the industrial motor control stuff, and for example, we have here in Sierra Vista, Arizona, there is a very large antenna test facility. It has a turntable that'll spin 80 tons, and it was made by the Matkin company that makes the rotating restaurants. The motor control from that is pretty awesome. Underneath it, it looks like somebody's big old turntable that you'd have at a house, but it's capable of handling massive weights. And in a case like that, we were using Galil motion controllers because they were designed to handle servo motors of that magnitude. When it comes to doing smaller stuff, the Freescale, of course, they have. I'm not really familiar with Infineon as much. I'm learning more about them as the days go on, and they're moving right up in the ranks as far as I can tell. But it's easy with the Freescale stuff. Everything is there. It's easy to control. And like we said earlier, you've got the different shields available or capes that allow you to go from one magnitude to another order of magnitude when it comes to controlling these devices. So, as time goes on, I'm thinking that the larger systems also will be controlled over of smaller and smaller devices because efficiency of all the components are increasing so much nowadays.
All right. Okay. Perfect. Unless anybody else has anything on motor control, I guess the next one that I'd like to hit on is MEMS sensing. Obviously, there's tons of different types of sensors out there, industrial and things like that, but specifically around MEMS sensing. And we see a lot of new boards and a lot of new developments around 9-axis. What are your guys' thoughts? Who's leading the pack there, and what is it that you're looking for to really integrate a lot of these newer technologies into your designs?
It's not an area I'm totally involved in, but there is a manufacturer beginning with M, whose name I've forgotten, that we do use. I think it might be Memsys.
Okay.
But yeah, I mean, for other types of sensors, then there's specialist manufacturers that we'll tend to, but also like Bosch as well, as an example. But for MEMS sensors, I'm not sure which ones we use.
Okay. All right. Anybody else using any kind of MEMS sensors or any thoughts around them? Is there enough information out there? Is it still too leading edge? What are you guys thinking?
Well, I've used accelerometers. I've even designed accelerometers in the past, and we've got currently there's Analog Devices, ST, and Freescale are all reasonable players, but there are actually a lot of others without such big semiconductor style names. I think the whole sensor field is very, very broad, so the big semiconductor companies are interested in mass production, so they're the kind of things you're going to find in phones and cars, which probably doesn't mean the leading edge in performance. Some of them are damn cheap, which is nice if you can get away with them. There seems to be, as you can see from some of the questions on E14, a staggering lack of basic mechanical knowledge, F equals MA and all that kind of stuff. People just don't seem to know it. And so I don't know that dev kits are really the answer there. It's sort of back to Newton and an apple is where we are. But it's a very, very big field. And I've with accelerometers and stuff, I've never used a dev kit. like it's very difficult to see what. Basically, the dev kit's just a breakout board for the chip, because as soon as you add a whole load of other stuff, it's really just confusing the issue a bit.
Yeah, if you see a lot of, I mean, I'm not pulling anybody out, but one thing I have noticed on like the Freedom platforms, a good amount of those actually have accelerometers just basically on there, which if you're doing a prototype and it's going to be doing any kind of motion sensing, things like that, the nice thing is that you have it on the board already, and you can at least get some rough idea of what the performance is going to look like, because it's already board mounted. Do you see those things being useful, or do you really stick more to using the industrial sensors and just
they can be useful. Obviously, they found a lot of use in phones where there's a great many accelerometers used to tell whether the thing's on its side or on its end, which is actually, it's a trivial application, but it is actually quite useful. And whether that spins off, I guess Freescale are doing it. They put the things on the boards because they're trying to increase awareness. And I guess they're so cheap that if they scatter them around like confetti, some of them will stick somewhere useful.
I mean, those things in particular, the Freescale ones, are so ridiculously cheap, is that they're actually cheaper than a tilt switch. So you can have a switch, or you can have a 3-axis device which you can talk to remotely, and has all the analog benefits. You measure just how well it's on one side or another side, or is it, how many degrees is it on one side or another side. And you might not need that, but it's there. So sort of ubiquitous, moderately accurate sensing. I mean, as you say, if you wanted something really good, then you're going to have to pay the money. But I think we've seen lots of sensor boards available on various sites these days, where you've got like 9 or so degrees of freedom of sensing board, which is like £5. It's absolutely ridiculous. I mean, they're really, 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 really cheap, and they work. You can put them on your Arduino. You can get information out of them, and quite literally, if you wanted especially now, obviously things like Mercury tilt switches are pretty much banned, and whatever else, and it's just like use electronics. You don't need a switch. It's ridiculously priced.
Okay. Yeah, well, I mean, you'd think since they're so cheap, you just want to start throwing them in things and figuring out what to do, what cool things you can add in. But all right, so that's wonderful. Anything else on sensors? If not, another area that obviously we've seen over the last 5 years or so, maybe even 10, is the changeover from bricks to more battery powered, as well as offline controllers. What do you guys think? Do you want to see more development kits in the power supply arena, for power management, or is it kind of you've got your base and that's pretty much what you use? You don't really need a lot of development kits, because that's obviously an area that we don't see a huge amount of growth in. But what are your thoughts around power management?
Personally, I think we need to see even more interesting test tools, to be honest. I mean, the kind of space I'm working in, I'm interested in wireless sensor nodes, the amount of power consumption they'll use, small battery powered devices. So in that area, I mean, some of the manufacturers of products that we use are like TI, Linear Technologies, Analog Devices. So yeah, usual players, I guess.
So maybe more around the lithium chargers and things like that technologies.
I think, yeah, because obviously these devices are available in various forms from in your products that you buy, right? But they're very hard to deal with on your own basis for low production.
Yep.
Right? And you can't always find all the information, because a lot of these things are probably Chinese only, or high volume only. We're not really interested in dealing with you type of devices. And I mean, fundamentally, what you'd like, of course, is like, as you're saying, especially for mobile devices, you want to charge them up, you want to put a battery on them, right? And you want multiple rails coming out, and you want it to be efficient. Right, you might have two inputs. You might have like a mains charging and maybe a solar power or something like this. Then you might have a battery, right, which might be 1 or 2 cells, generally speaking. And then you might need a couple of 3, 4, maybe even 5 different rails to supply on your CPU or your general peripherals. And you want it to work, and ideally you don't want to pay for it, right? And you know, and obviously someone somewhere is actually producing these devices, because there are actual physical end products using them, and their prices are right. But at the moment, they're not generally available for, I wouldn't say, well, certainly not for hobbyist line, but sort of like that transition area where we might design them into a product. So you say, oh, I want to make 10, 20, 50 of these things, and I'd like a device which will produce a couple of rails out, can be charged up, and uses a lithium battery, for example, right? And that would expand. And you probably say that sort of that area between sort of 50 milliamps and 2 amps, right? Overall usage, right? I think that covers quite a lot of the SBCs. And I think you probably could actually use a lot of the SBCs, which currently you try and think, well, maybe I don't really want to see them in my final design because I can't power them unless I've got a big lead acid battery or something quite awkward, right? But if you've got these different these devices which integrate some of these key functions, because you always want so many inputs, you always want a battery, and you always want a couple of rails, right, at very least, really, right? And as long as you got that, and then that's the kind of thing we'd like to see. You know, one that always does the trick.
So you're still thinking, and Michael, so basically you're still kind of in the, you know, I'm using more of an end solution than designing in power management on my own. That's kind of more of using modules or pre-existing solutions.
Well, it's a module to start off with, right? Because I mean, you get these devices, and they all seem to be quite sort of fussy in terms of their layout and the components, the ancillary components that come with them. Right, and you want it to work right the first time round, and of course it's quite handy, especially if you've got one which is configurable in terms of outputs and inputs. So you can say, well, I want a 3.3 volt output and a 5 volt output and a 1.8 volt output, and you can figure these things out. And I want to use 2 cells rather than 1, and maybe I want to, I don't know, solar power. Well, in that case, I don't want it to solar power in this instance, but I want just a normal 12 volt input or something like this from a car, right? And you stick them all together, get something working, right? And you say, well, that's, you know, you're probably getting good efficiency out of it, and you prove it, and you're getting that warm feeling out of, you know, I know what's going to go next. I can design that onto that board, and I feel that they're going to get something out of it at the end of it, rather than it's always that leap of faith. And the more leaps of faith in a particular design you have, the less likely you're ever going to finish it, or you know, it's always going to actually work.
Right.
So you just want to get these things together initially, and then go on.
Okay, Michael?
I think the big problem with power management is that layout is very important, and I think the idea of having a general purpose board, dev boards and stuff, they're not that useful. I think Linear Technology have got it right in that they've got a simulator and they do good simulation models for all their parts. It's a bit of a shame, really, that they couldn't share their simulation technique more with some of the other people, because other people like Intersil and TI have rather less good simulation packages. But generally speaking, if you want to custom power supply, you're going to have to design it from scratch. You're going to have to simulate it, and you're going to have to really know what you're doing when you lay out the board, else it won't work very well. But if you take a typical little dev board, and TI did quite a lot for their little power supplies, but all they could do is put the chip and the right sort of bits on a little square board. But that won't do you for a product, because in a product you're going to want a different combination from the one they showcased or whatever, different sized inductors, all sorts of things change, and they all matter. So it's a big problem. So I reckon a good simulator's worth far more than a development board.
And the layout. What about? Do you ever take any of the boards, like any of the demo boards? Do you take any of the layouts, or for people that may not have that much experience, if you have a good layout, and even though you're going to change inductors and transistor size or FET sizes, things like that, would you still reuse the layout just because if they've done any testing of it and let's say they show this design meets whatever FCC part they're going after, would you reuse that, or is that not useful?
I often look at them and I can't think of one that I've ever copied. It doesn't work because the demands of your particular product will usually mean you can't put the bits there, or you've got to use different bits. So it's always worth having a look to see what other people did. And in my experience, very rarely is it worth actually copying.
Am I right to think it's more useful for the idea than it is for the actual physical copying? Sorry.
Yeah, I mean, you'll see, say, on one of Linear Technologies' layouts, because that's one I know best, you'll see, they've taken a huge fat track to these 3 earth pins, and only a spidery one to that one. So I guess the one that's with the spidery track doesn't actually matter much. So it's worth copying that kind of stuff or paying attention. But they tend to do their layouts, they're a bit sort of blocky, and you wouldn't normally do track like that, and you'd have terrible problems soldering them in production as well. So you've got to take them with a bit of a pinch of salt.
Okay, great. Anybody else on power supplies?
I was just going to say, for like powered equipment, so maybe not battery powered, but just with a DC adapter or something, then there's quite a nice range of off-the-shelf DC-DC converters. I think it's Panasonic. They're really tiny. Farnell have them, and I've not personally used them just yet myself, but they're really low cost and really small. I'm pretty sure they're Panasonic ones.
Okay.
Yeah.
All right. Well, kind of on a I guess a somewhat similar topic. The last one that I'd like to go over is around wireless. And obviously, wireless is becoming, just a mainstay in everything. The question is, do we buy modules? Do we need more? Do we just use the embedded wireless in the kits that are coming out now? Where are you guys seeing the trend, and who is actually coming out with the best wireless solutions? Is it modules? Is it putting it embedded and having the traces on? Having the antenna on the board itself. What would you guys like to see, and who do you think is doing it right now?
I mean, well, for the products that I've seen, the actual the chipset's been used, but not modules. But having said that, I personally find the modules extremely valuable because obviously it's a reference design, but secondly, it's certified. You can just drop that design in. You'll have less certifications to do in different countries. So for me, I absolutely love the smaller modules as soon as they come out. But the only problem is that the manufacturers take a little while sometimes coming out with them. So they might come out with the larger evaluation or dev kit, plus obviously the individual chips, but the modules take a little bit longer. And also sometimes you might not be able to get exactly the thing that you want in a module. Like, for example, you might want 2.4 gig and 5 gig for 802.11, but maybe that's not available in a module form. So that's, some compromises.
Right.
Yeah.
Right. Anybody else on wireless? Anybody else any experience in the wireless arena with any of the kits or the modules?
Well, I believe if we have, I believe in the modules. If the modules are fully functional, as Shabazz was saying, and if it has everything you need, why not use it? Because it's already been set up. It has an antenna. It works. Some of them actually have external antennas that you can add. But the nice thing about the modularity is you can actually, you set up your board the way you want it, and all you got to do is feed it. Mm-hmm. And that's really appealing because you don't have to you don't have to have the headaches of trying to say, well, where am I going to put it on here that's not going to interfere with this? The nice thing about it is you can shield it up, put it in a box, and it's off to the side and doing what it needs to do.
What about certification? I would imagine that that's probably got to play a pretty big part in the decision-making process, because that's obviously not a simple thing.
Oh no.
It does. Oh, sorry. Steve.
Go ahead. No, you go ahead, Shabazz. It's up to you.
Yeah, I was going to say, yeah, it does play a role, but at the end of the day, the product requirements come first, and usually people want better performance, better range, and everything. So then you do end up with custom designs with custom antennas to suit the case, the enclosure, exactly where you place it. So I can understand why the modules are not used as much as I would hope to see them, but I think those are the reasons. But definitely
I mean, that's very much to do with the volumes, though, isn't it? I mean, sometimes if you can get to the market and get the devices out there, right, or your product out there a month beforehand, then even if your price isn't as good as whoever, right, it doesn't matter. You get it out there, and then once you start making some kind of profit on that device, hopefully, there's always going to be a new revision, and your sales are going to support the next revision, which may integrate everything into some mysterious super functional board. But initially, if you can get the modules running, then great. I think it depends obviously on the size of the organization powering this. If you've got lots of money, right, and you've got the skills on board to design we've just had here, if you've already got skills to design high power, you've got skills to design power supplies, you've got skills to do RF, then fair enough, because you've got those skills. You might say, well, we've already designing with these modules or designing with these chips. We'll just continue doing so, and we'll stick our own designs on there, right? But from a day-to-day basis, I mean, from a small-time operator, as it were, where you don't have all these skills just to hand, right? Then the modules are great because you can just get there, get it going, and a lot of the time you might just suck it up and basically say, well, it's a £1 module, sorry, a £1 chip or a £10 module, right? So obviously I'm losing £9 here, more or less, right? But of course I'm getting the antenna, I get into the design, it all works. I don't have to spend so many thousands of pounds having it ratified by the FCC or whatever else, or it's going to pass first time and not second or third time or whatever else. So it's, those are more important. And this is obviously about time and effort. I mean, if you're a small timer, you haven't got time and effort in terms of money. You haven't got time and effort in terms of skills or people, right? So to be able to buy that in and just stick it in and use it's great.
Yep.
I think for radio modules, then the sort of break-even point between making and buying is at a much higher volume for the radio modules, because if you say compare it with a little power supply or something, then the software tools and design tools you need for RF are vastly more expensive, and then the actual test gear is staggeringly more expensive. Now we can't all get a freebie like Shabazz, but that box is what, 10 grand for a basic RF test box, whereas if you think about the basic power supply test box is, well, a lot cheaper. So, and also for me anyway, RF's out of my comfort zone. Happy with the little power supplies, but not so keen on the RF.
If you're hanging around, Cliff, I'll look after it for you, okay?
Yeah, we'll do.
I think also price is not always the factor. If you just want the highest performance, then depending on the size of your enclosure, depending on how you're going to orient the antenna, it's all going to make have an effect on which antenna you want. So then you can't really use the modules. because there's just not enough of them. Normally there's just like 2 modules, one with a inbuilt antenna for a certain size, or one with a little MCX little connector thing on it.
But also, I mean, sorry.
Yeah.
I was going to say this, but also it limits you to what cases you can have. I mean, or you as I say, as a large producer, you could optimize everything so you get best price, best case, best everything. But and it's worth laying that upfront cost because you're going to produce so many of them. Whereas down in the lowly of old people down here, then we have you got those those per unit issues, and you're thinking, well, I just want to make. Sometimes you just want to make life easy and get it out there. I'll put up with the case looks a bit funky, and I'll put up with the fact that all this sort of business, and it's not quite so economic. But whereas, and the people who ask for those 1 to 10 off, 1 to 50 off type products, right, would obviously need to understand that basically, you can't achieve the same level of finish as someone producing 1 million off. And in that game, you say, well, you also can't have the same price benefits either, right? But there's lots of products which can be made and are useful, right? And there isn't a lot of them. You never hear, especially these, say, big industrial or niche products, right, which a lot of people are designing, right, and you never hear of them. This is where the practicality, you must be able to stick A to B to C, D, make a product, bind it all together, and get it out the door.
So do you see, I mean, if you're not using the modules, do you see the development kits themselves that are coming out now that basically have the they've got the antenna port on it, they also have the antenna laid out on there? Do you see these types of boards being useful even in terms of just having a reference for the antenna design? What are your guys' thoughts on those?
Absolutely. And some manufacturers go out of their way to provide tons of reference designs, like TI definitely does. They provide like 20 pages of technical documentation on each one of their antenna designs. So it's incredibly deep.
And that makes it easier for you to, I mean, that's the kind of stuff that if you're not going to go modular, that's the kind of stuff that you really need to, is that going to help you choose a particular manufacturer or choose a particular design because of the support and reference designs that they have for it?
Of course.
Yeah.
Well, you see designs and you see a lot of them come out and you see people use the same chips over and over and over again. Right, and you suddenly get confidence that you too could do the same. It might be irrational confidence, but indeed it is confidence. And that's the same with modules or whatever. You see them and you want to use them because you think they've used them, they work. I want one of them.
Yeah. So Shabazz and Steve, you guys were saying, Shabazz, you're saying TI is real strong. Anybody else, or are they leading the pack, or who else do you see that's really providing the right tools for it, the designs?
TI puts a lot into theirs because they want to put their best foot forward. So they actually put a lot of money into development of this development board. Because if you take it, when we put this thing together, we want to put it out there real fast. They're not. If they don't do their homework in the placement of the antenna, the shielding, and everything else, they don't go through those steps to say, hey, look, this is my best offer right here. It is the best thing on the market. If they don't actually believe it themselves, how are we supposed to believe it? So they want to. The idea is they've done their homework. They've got the antenna in a position where it's most effective, most efficient use of the real estate that the chip is mounted on. That means a lot because it shows that they believe in their product enough to show you how it works. So in a case like that, it's to your advantage to follow their lead on that. And if if they provide a lot of specs with it, that means they're backing up what they're showing.
Okay.
I mean, that's very much the case. I think a lot of these designers or designs that you see, they have big X here, so this is stick your antenna here, it'll work honest, right? And yeah, you find out that no, it doesn't quite work as well as intended, and yeah, and there's these little caveats that you've it is generally speaking are in the technical data, but they've been sort of brushed over to the point where they're not really there, and you bought into it, and you think, oh dear, this is a bit of a poor effort. I'll stick this for something else somewhere.
Right.
I'll take it on board as a bit of a bad job. And I must admit, I haven't really used the Texas Instruments devices much. I think, except for indirectly, Syseko, right? And they use some of the ChipCon, which is obviously TI, and those devices work very well, right? It'd be very simple, very bulletproof, and you'd want to use them, I think.
So, Shabazz, would you say, I mean, so it sounds like we're pretty much all in consensus that this is one development kit that people will use as reference design if it's done well. It's kind of pick and place, go ahead and put it on my board as is.
Absolutely, and TI go to the point of, like, for example, this is one of their development boards, and they'll even mark on the actual module exactly the kind of area which you can replicate if you want to use that design exactly as is. And the other cool thing is, obviously, with that acquisition of ChipCon and their microcontroller technology, they've got other modules which have got built-in microcontrollers as well. So whether that's 8051 core or ARM Cortex one. So they've got a wide range. I mean, that's not the only wireless vendor. There's other ones that are doing a similar thing. But I think, I mean, we see evaluation modules from other vendors as well. But the TI ones are the smallest in terms of the bare minimum. So they'll put exactly what you need on there, and then they'll put everything else on a single larger board, like a motherboard, that you plug it onto. And that approach is really nice because I can, if I wanted to, I could literally unplug that and just wire that directly to a different microcontroller if I wanted to. I wouldn't have to use the one on board on the.
Are there? That's. I guess my last question is: are there any technologies or any other development kits that you would like to see be designed more as reference designs, where you really could cut and paste? Are there any? Is there anything else out there that I remember years ago? You know, like high-speed memory traces. People were taking the company I used to work for. They were taking our app notes and physically saying, "Is this a one-to-one PDF?" and copying it. You know, are there any other development boards that you'd like to see more true reference designs done around? Any technologies?
Before we move on, can I?
Yeah, sure. Oh, yeah.
Chip in on the RF. I think the other two companies well worth looking at are Scilabs, who've got quite a nice offering and quite a lot of interesting development bits and pieces and a reasonable track record in support. And the other people have quite a lot of bits, but a less good record in support, or Atmel, but they're probably, if you're choosing a new chip or module, they're worth looking at. And if you're just going for a module, then Microchip may be worth considering because they have a good track record on price and availability. Sorry about that.
No, that's perfect. Yeah, sorry. It's hard for me to keep track of everyone, so I appreciate you jumping in there. Anyone else on the wireless, or Shabazz, you were saying something about you know, what you'd like to see in development kits, or more towards the reference design?
Yeah, I mean, to be honest, even if it's the simplest part, I'll always try and look to see if there's a layout, just to glean any information, and obviously read the data sheet back to front. So sometimes I think it's not that the manufacturers don't want to supply it. I think they sometimes forget. So they'll mention in their documentation that there is an evaluation board or something, but actually forget to put the link for the actual layout, or they might not have it on their website. But interestingly, for a lot of stuff, I found some of the manufacturers, like Freescale, they'll put the documentation on the Element 14 community site, even if it's not on their corporate site. So that's like becoming more and more like a resource for getting that kind of information.
Yeah, it's good to hear from our side. Anybody else? Any requests for the manufacturers before we head this one off?
Well, I'd like to see some more FPGA breakout boards. All of the FPGA people do a range of often quite complicated boards. It's mainly been Lattice have been about the only people to do something which was sort of breakout board with a power supply, and increasingly with some sort of debugging or programming chip on, which is usually just one chip. It'd be really nice if some of the others would do that, because with these big FPGAs or even moderate-sized ones, they're often in things like 300 ball plus BGA packages, and that is a bit of a nightmare for a one-off board to see if you like the chip. On the other hand, I don't fancy parting with £1,000 or more for a board that's stuffed with other things. So I think you guys have just brought out a board with an Altera FPGA on, and not particularly interested in that particular FPGA, but I can't help but feel it would have been. I'd much rather have seen that board with the FPGA and nothing else on it, because all that peripheral stuff really just makes it confusing and difficult to use. So yeah, simple breakout boards for FPGAs. I
think Lattice have a bit of reputation for that, don't they?
Yeah, well, they have this wonderful market slogan, the ultra low density, and they've sort of taken that to the limit.
Packing it in, huh? Yeah, okay.
I think some high-speed ADCs would be quite interesting, because I've got a bit of a SDR thing at the moment, so there's some of those high-speed ADCs on a again on a minimalist board, just enough to make it work, right? And that's the problem, because I say a lot of them want to integrate lots and lots and lots of extra functionality, and a lot of people that want to use them just want them to save putting a board down onto specifically high density device onto a board. Just want to get it going, feel comfortable with it, then actually go forwards with a design later on. So those kind of things would be nice.
Okay. Good to see. That's good. That's good input. All right. Anyone else? If not, I greatly appreciate everybody's time today. Actually had some really good conversations, and appreciate your frankness. So with that, Jen, I'll hand it over to you. Yep, I think Jen's on mute. Oh, wait, well, maybe not.
Now she muted again.
And now she muted herself. Oh. Okay. Well, if it makes it easier, I'll go ahead and close this off today. Thanks, you guys. I really appreciate your time, and it's been really valuable. And look forward to keeping speaking with you, and stay active. We do appreciate you, all your support and all your inputs on the community. So thanks for being loyal customers, and we'll talk to you guys soon. Thanks very much.
Bye.
Take care.